Let's take a look at our print list function. On the left hand side is the code for the print list function, and on the right hand side is the code for main. In this white canvas is a pictorial representation of our linked list. We enter main, so let me create an activation record for main. And in main we have one variable, and our variable is head. And let's pretend that we've already completed the push head functions 3 times, and this is what we have currently. Our head will be holding the address of 0x300 after we go through these function calls. And then we get to this line where we are trying to print the list, so let me create an activation record for print list. So in print list we are assigning the address of head, because head is a pointer, so therefore it's an address variable. And if you look at line 91, where we are passing the address of head. So here I'm going to create head, and that is holding the address of 0x50. And what is 0x50 pointing to? It's pointing to this first node. But first, before I do that, let me target the first condition. In the condition where a head isn't pointing to anything, it's just pointing to null, then it's going to go to line 95 and print the list is empty. And then it exits out of the function, and the print list function is popped off the stack. Now in the case where our list is not empty, and in this case it's pointing to the first node, it's going to take a look at the data, which is 40, and the output, in this case 40. Head will be pointing to the head next, or the head next will be assigned to head. And so what is the address of the head next is going to be 0200. And so this head will now point to the second node, and the address it is holding is 0x200. And then we go to line 98 and we ask the question, or the compiler will check, does head equals null? Well, no, the head equals 0x200. And again, it's going to go to line 100 and it's going to print out the data that that node is holding. And in this case, it's 25. And then in line 101, it's going to assign head the address of head.next. And what's the address of head.next is going to be 100. And now head is pointing to the last node. And then it goes to line 98 again. Does head equal null? Well, no, it's pointing to 0x100. So we go to line 100 and it's going to print out that data. Then we go to line 101 and it's going to set head or assign the address of the next to head. And in this case, what is the address of the next is null. So now head will be pointing to null. And then we go back to line 98. Head does not equal null. Well, that condition now is false. This function is executed or completed. This print function gets popped off and we get our output 40, 25, 15. For our purposes, this print function works just fine. But as we begin to add more nodes to our list and we get up to, let's just say, the hundreds or even the thousands, I want to modify this a little bit. And the first thing I want to do is add another pointer, because whenever you're creating a linked list, you're not limited to one pointer. And technically, our head should always be assigned to the first node. And so I'd like to keep it that way. I don't really want to move head to or traverse head to the second node, to the third node, or to the nth node. I want to keep it at head. And so let me create a print list activation record in the stack, or in our argument, we're going to pass head, and that's holding the address of 0x50. And since 0x50 is pointing to 300, this will also now point to 300. And so what I want to do is, I want to create a second pointer, and I'll call that current. Here, we're going to go node star current, and we're going to set that equal to head. This is going to be our current pointer, meaning this is our pointer is currently pointing to the current node. And what I want to do is, instead of saying while head does not equal null, I'm going to change this variable to current. So while current does not equal null, and then I'm going to change this to current data, because now we are traversing our current pointer and not our head pointer. So this will be current and this will be current. And let me just print this to make sure that I don't have any errors. And there it is, 40, 25, 15. Now there's another thing that I want to do. I want to make it a little bit more specific because I want to be able to identify what's index 0, index 1, index 2. And so I want to add another variable here. And I'm going to call this, it's going to be an integer, and I'm going to call it I for index. And we're going to set that equal to 0 because that should be our very first index, 0. We go here, current doesn't equal no. It prints, it goes to the next data, but here I want to be able to identify what node number it is. So I'm going to put node, and then in brackets, I'm going to put %d, our format specifier for integer. For that format specifier, I want it to be I. And then after we print that, we want to increment I, our index. So all we're going to type here is I plus plus. And let me print this. So there it is. Node 0 is 40, node 1 is 25, node 2 is 15. It's pretty much the same logic that I've explained before. The only difference is instead of head, I've created a current pointer. Current is pointing to the same address as head, and head is holding 050, so therefore it's pointing to 0x300. That's the parameter that we pass. And then we create an integer variable, I, to hold our index data. And so here, while current does not equal null, well, current is, this condition is true because current is pointing to a node address. We print the data, and currently, where it says node %d, our I right now, let me put I right here, our I, and then I'll put data right here. Our I currently is 0, and so we're going to print 0, and then we're going to print the data, which is, in this case is going to be 40. And then we increment I, and I becomes 1. And then we're going to set current to the next node, and then we go back to line 100. Current does not equal null. That condition is true, and so we print the node, and in this case, our I is currently at 1, so we print that, and then we print the data, and in this case, our data is 25. And then we go to line 103 and we increment I, so now I becomes 2. We set our current to the next address, or we assign the next address to current. So this was holding 200 before, that was holding 200, and now it's holding 100. I forgot to update that, but you get the point. So now this is holding 100 and it's holding this address. And so now we go to line 100 again. As we iterate through this while loop, does current not equal null? And that is true. We print our node, and I is currently at 2, so that gets printed, and our current data is 15. And then we increment I, and I becomes 3, and then we set current to the next link. Well, what is our next link? Null. So current now holds the address of null. We go back to line 100. Current does not equal null. Well, that condition is now false because it does equal null. We complete the print list function. We exit. The print list is popped off, and this becomes our output. Let me build and run, and there it is. Node 0, 40. Node 1, 25. Node 2, 15. So that is our print list summary. And again, notice how we're keeping head at our first node just to be more accurate, and we're traversing our second pointer current to print out our data. And we've added a variable I, an integer variable, to store our index address. I hope that you understood this video. Thank you.